Good morning, all of you. I'm Miss Amrita Zadav, ma'am, your physics teacher, and I'm welcoming you to the part 8 of Thermodynamics, in which we are going to deal with one single concept which is really very interesting and which is being asked in board examination many times. So, that concept is heat engine. Okay, so before moving towards our part, we will discuss the previous lecture first and then we'll move towards our today's lecture. So let's move towards the revision part. So this slide will explain you what points you have learned in the previous lecture. So we have learned classifications of thermodynamic process, which was in the two parts. In the first part of this classification, we have discussed three processes, which was reversible and irreversible process, then isothermal process and adiabatic process, and even isobaric process. And now after that we have discussed four more processes, which was isochoric process, then adiabatic process, cyclic process, and free expansion. So these four we have discussed in the previous lecture. So what was the isochoric process? In isochoric process, volume or pressure remains constant. So when you are discussing about isobaric and isochoric is the process in which volume is always remains same. That means delta V is equal to 0. While adiabatic process is the process where there is no transfer of heat from the system or to the system. So heat exchange is constant over there. So you can call it as Q is equal to 0 in case of adiabatic process. Now the third one, which is cyclic process. In cyclic process, the process in which the procedure continuously flowing from initial to final state variables and which is always continuously moving is known as cyclic process. The thermodynamic process that returns the system to its initial state and again it goes back to the final state, and this happens circularly, cyclically. So this is known as cyclic process. So in this case you can say that delta U is always 0 because it is continuously moving from initial to final. So internal energy is 0. Now the last one, which is free expansion. In free expansion, Q, W and even delta U, all the three terms which deals with the first law of thermodynamics, all are 0. Why is it so? Because this expansion is completely free expansion, so it got freely move within the system. So Q, W and delta U becomes 0 in this case. So this is all about the classification of processes. Now why we have studied all such processes in this? Because we are going to deal with a device which is been using one of the process, which is cyclic process. So what device is it which uses the cyclic process? So let's move towards the forward. We'll give you the answer for this. What is the question? Which is the device which uses cyclic process for their procedure, for their motion? And what is that? So let's move towards the next slide. And the answer is heat engine. Okay, so the point which we are going to learn today is nothing but heat engine. We are just going to study some terms, that means how it works, what are the terms which are including in heat engine, what are the elements, there are some types of heat engines, that all points we are going to cover in today's lecture. So the point which is heat engine. So basically you can see in the following diagram over here, which will give you some kind of idea in which You can see over here heat, expansion, cool, contraction. So what exactly it gives you? It converts the heat energy into even the work done, because when heat is being applied to it, this piston is moving up and down. It continuously moving, and when it moving, this disc is moving, and as it is moving, so work done has to be done. So the heat engine is being converted into work done, or I can say not all the heat is converted into work, but some work is been exhausted. So to remove that, or to do not exhaust it, we have given a tap over here. That tap is cooling that work substance. Okay, so this is not the exact heat engine that we are going to discuss. We are going to just see the basics about heat engine. This is the example of it. Some example should be there. So this is the example of heat engine. Okay, so let's move towards the lecture, which will give you idea about the heat engine. So as I told you, heat engine is a device which converts some heat into work. Okay, now I said that some heat into work. So where does the other heat goes? So that other heat goes to the exhaust. It goes in forms of exhaust. Okay, so it get lost. So I can tell you that the device which convert heat into work and each other. Why I am saying to each other? Because it is a cyclic process. So this heat engine works by the process of cyclic. It uses a cyclic process. Now I can say that it converts the heat energy into work or into mechanical work. Now why I am using the mechanical work? Because we seen that the example in which piston is moving up and down, it continuously moving. So as it is continuously moving, there should be some force. So when we are dealing with a term which is force, we can call it as mechanical energy. So that comes out to be the mechanical. So as we are going to study about heat engines, so mechanical work or mechanical energy should be there. So the heat engines are the device that transforms heat partly into work or into mechanical energy, and it deals or it works by using cyclic processes. So that's the main part of the heat engine. Okay, it involves all the changes by using cyclic processes only. So the first, which is most important about heat engine, is heat is partly converted into work or into mechanical energy. And second thing which is important about it is the work is by using cyclic processes. Okay, now we'll move towards the next point, what exactly it deals with. So now as we are saying, it is a heat engine. So where does the heat came from? The heat which is came from or received from a source, some kind of source. As we have seen in the earlier slide, there was a engine which was the automobile engine or any engine that gives, you can see over here, the source was directly burners. You can see over here, heat is being provided by burners directly. So the heat engines receives heat from a source, and we are going to call it as reservoir. So the heat which is being received by reservoir and will be converted into work done. Okay, so as the third point that we have discussed, which is about reservoir. What is reservoir? Heat engine receives heat from a source which is known as reservoir. Okay, then let's discuss about the typical heat engine. as we said that it is the engine, it should have some elements which are common in all the types. So there are some elements which deals with or which gives you idea about a heat engine. So let's discuss about that. So here are the elements which gives you idea about the heat engine, and the first one is working substance. Okay, so working substance is first element which gives you idea about heat engine. Second, which is hot and cold reservoir. So as I told you, what is reservoir? It is a source which is giving heat to the engine. So it is either hot or cold, so it is both. We are going to use both of them, hot and cold, because as we discussed earlier that not all the energy is being converted into work, but some will be absorbed, some will be exhaust, so that will be a cold reservoir. Okay, and the last element which is being used in heat engine is cylinder. Obviously, when we are going to deal with any kind of working substance or a system, that has to be enclosed in some kind of material, some kind of apparatus, that nothing but cylinder. Okay, so this all is being enclosed in a cylinder. So this is the third point or third element of a heat engine. So these are the some elements. First is work substance, second is hot and cold reservoir, and third one is cylinder. So let's move towards the next slide. Okay, now we are going to discuss one by one each of them. Now what was the first one? The first one was a working substance. Now what is working substance? As it works, and substance means system. So it is nothing but a system. It can be ideal gas for ideal heat engine. Now, right now we are not going to discuss about ideal heat engine. We will discuss it later. We are just going to discuss only a heat engine in this part. Okay. So, in case of that, ideal gas can be used as a working substance. Okay. And for practically heat engines, the working substance can be a mixture of fuel, vapor, air in gasoline. That means petrol, diesel engine. Diesel is there, petrol is there, or fuel vapor is there, rocket petrol is there, or steam in case of steam engine. So these are the working substances. Okay, have you got this point? For practical heat engines, we use working substance as either petrol or diesel or steam in case of steam engine, or fuel vapor, or it is a mixture of fuel vapor and air. Okay, so this is the working substance for the heat engines. Now as we discussed that it is a working substance that absorbs heat and does work. Obviously, when it going to absorb all the kind of heat, and then it will do work. So working substance will be absorbing heat. Now where it will absorb the heat? Obviously it will absorb heat which is given out by the source, and the source is nothing but reservoir. So let's move towards the next point, which will explain you the concept regarding reservoir. So I hope you got this concept. What is working substance? वर्किंग सबस्टन्स म्हणजे इट इज नथिंग बट अ सिस्टीम आहे. जर का आपण आयडियल हीट इंजिन कन्सिडर केलं तर आयडियल हीट इंजिनमध्ये वर्किंग सबस्टन्स असणार आहे आयडियल गॅस. ओके, अदरवाईज ज्यावेळेला आपण हीट इंजिन कन्सिडर करतो ते डिफरंट फॉर्म्समध्ये असतं, डिफरंट टाईप्स असतात हीट इंजिन्सचे. स्टीम इंजिन असू शकतं, डिझेल इंजिन असू शकतं, पेट्रोल इंजिन असू शकतं. सो इन दॅट केस आपण जर का गाडी कन्सिडर केली आपली व्हेकल, तर व्हेकलमध्ये पेट्रोल आपण यूज करतो. सम फोर व्हीलर्स डू गेट द डिझेल, दीज आर द डिझेल इंजिन्स. सो ज्या व्हेकलमध्ये पेट्रोल लागतं, सो त्या इंजिनसाठी वर्किंग सबस्टन्स आहे पेट्रोल. ज्यांना डिझेल लागतं त्या इंजिनचं वर्किंग सबस्टन्स आहे डिझेल. आणि जर का मग स्टीम इंजिन म्हटलो तर स्टीम इंजिनसाठी वर्किंग सबस्टन्स काय असणार आहे, स्टीम ऑब्व्हियसली. आणि अदर जे प्रायमरी इंजिन्स आपण म्हणतो त्यामध्ये मिक्सचर असतं फ्युएल वेपरचं आणि एअरचं. ओके, सो दीज आर द टाइप्स ऑफ इंजिन इन विच वर्किंग सबस्टन्स चेंजेस. जसं आपण आधी म्हटलो की आयडियल हीट इंजिन कन्सिडर केलं तर आयडियल गॅस यूज करणार आहे. पेट्रोलसाठी पेट्रोल वर्किंग सबस्टन्स, डिझेल इंजिनसाठी डिझेल. ओके, सो हे आहे अबाउट वर्किंग सबस्टन्स. मग एक्झॅक्टली काय होतं वर्किंग सबस्टन्सने, तर वर्किंग सबस्टन्स ॲब्सॉर्ब करतं हीट आणि ते वर्क डन प्रोड्यूस करतं. ओके, इट ॲब्सॉर्ब द हीट. आता कुठून करणार आहे ॲब्सॉर्ब, तर कुठून तरी येईल हीट अँड देन इट विल ॲब्सॉर्ब अँड इट विल डू वर्क. सो द टर्म फ्रॉम वेअर इट गेट्स द हीट इज नथिंग बट सोर्स. तर एका सोर्सकडून हीट मिळणार आहे त्याला आणि त्या सोर्सला आपल्याला म्हणायचं आहे रिझर्वॉयर. ओके, सो द नेक्स्ट पॉईंट आहे विच डील्स विथ हॉट अँड कोल्ड रिझर्वॉयर. ओके, so let's study about hot and cold reservoir. Okay, the working substance interacts with reservoir, that is the first point. Okay, hot reservoir is a source of heat because it is giving heat to the working substance as a source of it. Now, and it is at the relatively higher temperature. Okay, now hot reservoir it at higher temperature and providing a large amount of heat to the working substance or to the heat engine, and that temperature is called as TH, temperature higher. So H stands for higher. Okay, and it is nothing but a source, it is known as source. And the second term which is there inside a heading which is cold reservoir. Now what does the cold reservoir does? So as the heat is being given to the working substance, some heat is being absorbed, so that absorbed by the cold reservoir. So the cold reservoir absorbs large amount of heat from the working substance at lower temperature which is TC. Okay, temperature which is lower TC, and it is for the cold reservoir. So that's why we are calling it as TC, and it is also known as sink. So the heat or hot reservoir is known as source and the cold reservoir is known as sink. What does the hot reservoir does? It gives out the heat to the engine, heat to the working substance, and it is at higher temperature. So it is known as TH. And cold reservoir is nothing but it absorbs the large amount of energy and it cools down the heat engine. So that is cold reservoir and it is known as sink. Okay, so this is the basic difference between source and sink. What is source? It deals with the higher temperature and it gives out the heat, and sink is nothing but it is at lower temperature and it absorbs the heat. Okay, so this is all about the hot and cold reservoir. Now the last term, which is nothing but cylinder. Now what is exactly a cylinder? As we told you, or as we discussed earlier, that all these things is being enclosed in some kind of material, some kind of apparatus, that is nothing but cylinder. So this all is being enclosed in a cylinder. The working substance is enclosed in cylinder with a moving frictionless massless piston, and working substance does some work by displacing the piston in the cylinder. Here's all the points, these all the points, हे जे सगळे पॉईंट्स आहेत ते आपण रेग्युलरली आणि कंटिन्युअसली एक्सप्लेन करतोय. Cylinder, movable frictionless massless piston which is moving in upward and downward direction, ज्याच्यामुळे कॉन्ट्रॅक्शन आणि एक्सपान्शन होत आहे, ज्यामुळे वर्क डन चेंज होत आहे, इंटरनल एनर्जी चेंज होते आहे. हे कॉमन आहे विदिन द थर्मोडायनॅमिक. ओके, कारण आपण थर्मोडायनॅमिक चॅप्टर कन्सिडर करत असताना आपण ॲज अ एक्झाम्पल सिलेंडर विथ पिस्टन हेच कन्सिडर करणार आहोत. सो इन दिस केस ऑल्सो वी आर गोइंग टू डिस्कस अबाउट द सेम थिंग. सो म्हणून आपण इथे म्हटलो आहे की वर्किंग सबस्टन्स जो आहे दॅट इज बीन एन्क्लोज्ड इन व्हॉट, इट इज एन्क्लोज्ड इन सिलेंडर. तर सिलेंडर आहे म्हटल्यानंतर त्याला काय असणार आहे, पिस्टन असणार आहे. हीट अप्लाय केल्यानंतर ते पिस्टन अपवर्ड आणि डाऊनवर्ड डिरेक्शनमध्ये मूव्ह होणार आहे. सो वेन इट इज मूव्हिंग, वेन देर इज अ मोशन ओव्हर देअर, व्हॉट विल हॅपन, वर्क डन. सो वर्क डन मिळणार आहे आपल्याला. सो दिस डिस्प्लेसमेंट इज ट्रान्सफर्ड टू द एन्व्हायरमेंट युझिंग सम अरेंजमेंट. आता हे कसं ट्रान्सफर होईल टू द एन्व्हायरमेंट, तर त्यासाठी एक अरेंजमेंट आहे. अँड दॅट अरेंजमेंट इज नथिंग बट crankshaft, and which transfers the mechanical energy to the wheels of the vehicle. आता इथे त्यांनी इंजिन कुठलं कन्सिडर केलेलं आहे, तर व्हेकलचं इंजिन कन्सिडर केलं आहे. त्यामुळे तिथे यांनी स्पेसिफाय केलं आहे की दॅट crankshaft, by using that crankshaft the displacement is being transferred to the environment. ओके. आणि ते का होतं एन्व्हायरमेंटमध्ये ट्रान्सफर, तर त्याचं कन्व्हर्जन होतं मेकॅनिकल एनर्जीमध्ये, ज्यामुळं व्हील्स रोटेट होतात व्हेकलचे अँड देन व्हेकल कॅन मूव्ह. कळालं आहे इथपर्यंत? ओके. सो नाव ॲज वी डिस्कस द एलिमेंट्स विच डील्स विथ द हीट इंजिन, बेसिक concept of heat engine. Now we'll see some types. There should be some type of heat engine. All right. So there are two types of heat engine, and which are they? So the first type of heat engine is nothing but external combustion. Now, what is external combustion? So, when working substance is hit externally, it is known as external combustion. So, this is one kind of heat engine. And when working substance is heated internally, then it will be known as internal combustion engine. Okay, so these are the two types. Which are they? Again, I will tell you. The first one is external combustion and the second one is internal combustion. What happens in an external combustion engine? Working substance is heated externally. That's why it is known as external. And when the working substance is heated internally, it is known as internal combustion engine. Okay. Now what will be the example of both of them? External heat engine is nothing but steam engine, because it is being heated outwardsly. Working substance is heated externally in case of steam engine, and when it is heated internally, it is in automobiles. By using diesel, petrol, it get heated. So internal combustion engines are nothing but the automobile engines. Okay. Now, any heat engine can work with the basic 3 steps. Now, which are the 3 steps? We will discuss in this slide. The first step is the working substance absorb heat from a hot reservoir at higher temperature. This is the first step. What does it do? The working substance absorb heat from the hot reservoir, or we can call it as source, at higher temperature, which is TH. Okay. And second part is part of it absorbed by the working substance and it is converted into work. So what happens when heat is being applied to it? It will get absorbed and it will do work. That is the second step. And the third step is the remaining heat is transferred to the cold reservoir, which we are saying as sink. So the remaining heat is transferred to the sink at lower temperature and we call it as TC. So these are the 3 basic steps. What was the first step? First step was working substance absorb the heat from source. Second, part of it is absorbed by the working substance and it is converted into work. And third, remaining heat will be transferred to the cold reservoir, which is sink. Okay, so these are the basic 3 steps. All these terms are deals with source, work done and sink. Okay. Okay. So this will be in a continuous process because it deals with the cyclic process. So it will be continuously from source, work done, sink. Sink, work done, source. So it is moving continuously. So that's why it is known as a cyclic process. Okay. So here is the schematic diagram which gives you the idea about it. The first, the upper part is nothing but, here you can see, what does the upper part represents? The upper part represents the hot reservoir, lower part represents the cold reservoir. That's why it is given out by a red color and this is by violet color. Okay. Now this is suppose a engine. So what happens? Hot reservoir will be gives out in terms of work and some will be given out in terms of cold reservoir. So that's why the arrow is in such a way. What happens? Hot reservoir will convert that into work done, which is W, and some will be to the cold reservoir, which is at TC. Okay. So what will be input? Input will be from the hot reservoir and output will be this. Cold reservoirs terms will be nothing but the output and even the work done. Okay. So we are going to see the mathematical formation of this equation which is given in this diagram, which is W is equal to QH plus QC. What will be QH and QC? We are going to discuss in the next slide. So, as we discussed that heat engine can be classified according to the working substance used. Okay, and some steps which are followed by all the heat engines that we have discussed in the earlier slide. Now we are going to see the actual steps which are involving in heat engines. We have seen the diagrammatical representation of that is diagrammatical representation of energy flow diagram that we have seen. Now in that you may observe that there are some terms which are unknown to us. The first term which we haven't discussed was QH, QC and this. So where does it come? Let us discuss, let us find out where does it come. So we are going to consider the QH is the heat which is absorbed by the working substance at source. QH is nothing but heat absorbed by the working substance at the source. As we know, source is at higher temperature, so the temperature for the source is TH. So that's why we are calling that heat as QH. Okay, because it is for hotter one, that's why H is there. Now the next, which is QC. What is QC? QC is the heat rejected and it is given to the sink. So it is QC. Now what will be the sign conventions for both of them? One of them is positive and another one is negative. So as it is being absorbed, the first one which is QH. So QH is positive and as QC is being rejected and given out to the sink, so QC is negative. So this is really very important, which is when we are considering about the heat which is absorbed, it is considered as positive, and the heat which is given out to the sink or rejected, it is nothing but the negative one. Okay, so even as we say that the work is being done by the working substance as it been heated, and from where it got the heat? It got the heat from the hot reservoir or from the source. Now in the diagram you can see that here in the diagram you can see that the circle which represents the engine, you can see the circle over here, so that represents the engine. and the heat pipelines shown in the diagram represents the heat absorbed, rejected and converts into heat. These arrows are giving you ideas about where does the heat goes. Some heat is goes to the work done part, some heat is goes to the cold reservoir, and some heat is been absorbed. So the arrows will give you idea about it. Now the width of heat pipeline indicated by QH. You can see over that this QH. This will give you idea about the width of it of pipeline, and width of branch indicated by QC. Here, here and here. Branch has been indicated by QC, and the width of heat pipeline indicated by QH. So the point where heat get absorbed is QH, and the point where heat get in outward direction or given out is given by QC. Okay, the width of branch of the pipeline indicated by W. You can see over here the another one here. The width of pipeline is indicated by W, and it will be proportional to the part of it converted into mechanical work. From what it depends on obviously a source of it. So the work done which is depending or proportional to the part of it. So as we mentioned earlier that it always does a process in cyclic process. So it is been continuously moving. This cycle or several such cycles are repeated when heat engine operates. So the quantities QH and QC represents the amount of it absorbed, which is positive, and amount of it rejected is nothing but negative. Okay, so in first cycle when it is positive, in second cycle it will be a negative. So as it is continuously moving. Now as you may heard that some RPM term. What is RPM? RPM is resolution per minute. So the number of repetitions of the operating system is indicating the RPM, rate per minute. What is that rate per minute? It is the number of repetition of a cycle inside a engine. Okay, sorry. So we'll move towards the next one, which is as the heat is being converted or considered in two types, which is QH and QC. What will be the net heat absorbed to the or to per cycle will be Q is QH plus QC, or we can say it as Q is equal to mod of QH minus mod of QC. Why we are giving mod to it? Because as we said that will be either positive or negative, and according to the cycle it becomes positive and negative. So we are giving mod over here so as to ignore the sign. Now the net work done will be what? The work done in one operating cycle by the working substance is given by the first law. What is the first law? Q is equal to delta U plus W. As delta U, as it is a cyclic process, we said that delta U is nothing but 0 in case of cyclic process. So the work done will be only Q, which is heat provided to the system. So we can call it this as W is equal to Q. So what is Q over here? It is nothing but QH minus QC. Okay, so we would expect that a heat engine to convert all the heat or absorb heat into work done, but practically it is not possible because some kind of it is being exhausted or it is being given out to the cold reservoir, which is sink. So not all the heat is converted into work done. Okay, so we are going to discuss one term, so which is nothing but thermal efficiency. What is thermal efficiency? Which is given by eta. This sign is known as eta, and it is being given by the formula which is eta is equal to W by QH. As we said that not all the heat energy is absorbed. There should be some energy which is converted into work done, or some will be absorbed by the sink. So QC will not be 0 for the heat engine. It will not be 0. Okay, so to find out the term or the for thermal efficiency of any heat engine, we have considered a new term which is eta, which is thermal efficiency, and it is given out by the ratio of work done and amount of it which is absorbed. Okay, so what is efficiency? It is fraction of heat absorbed that is converted into work. So as we know that the value for W, so as eta is equal to W by QH, we can call it as 1 plus QC by QH. Where we are saying that 1 plus QC by QH because W is nothing but QH plus QC, and as here is the QH, so by separating the terms, QH by QH will be 1 and the second term will be QC by QS. So that's why we are getting this 1 plus QC by QH. Now as this is the cyclic, sometimes it will be positive and sometimes it will be negative. So in front of that we have written in negative sign also. So we are getting eta as 1 minus mod of QC divided by mod of QH. So what does the ratio gives out? The ratio is giving out energy. Okay, so this ratio is nothing but, or it represents the energy. Now is it have unit for efficiency? No, it will not have the energy because these both terms are equal. So the unit will get cancelled. So the efficiency has no units. Okay, because QH and QC both will have the same unit and it will get cancelled. So this is all about the efficiency. So what we have discussed in this part, we have discussed heat engine. Okay, I will give you summarization of all the heat engine in Marathi right now. Now what we have discussed in heat engine, पहिल्यांदा आपण काय पाहिलंय, heat engine is a device. कुठले कुठले पॉइंट लक्षात ठेवायचे ते सांगते. Heat engine which converts heat into work done and even it absorbs it. हा फर्स्ट पॉइंट आहे. कुठली प्रोसेस यूज केली जाते फॉर हीट इंजिन? सायक्लिक. सायक्लिक प्रोसेस इज बिंग यूज्ड, ही सेकंड टर्म आहे. त्यानंतर काही एलिमेंट्स फॉलो केले जातात फॉर हीट इंजिन. ते 3 एलिमेंट्स आहेत. त्यातला फर्स्ट एलिमेंट आहे वर्किंग सबस्टन्स. आता वर्किंग सबस्टन्समध्ये काय पाहिलं आपण? पेट्रोल, डिझेल, गॅस, दिज आर द वर्किंग सबस्टन्स. आयडियल इंजिन कन्सिडर करतो त्यासाठी आयडियल गॅस आपण वर्किंग सबस्टन्स म्हणून कन्सिडर करणार आहोत. सेकंड एलिमेंट आहे हॉट अँड कोल्ड रिझर्वॉयर. हा एक पॉईंट पाहिला, एलिमेंट पाहिला. अँड द थर्ड एलिमेंट वॉज सिलेंडर. आता हॉट आणि कोल्ड रिझर्वॉयरमध्ये काय पाहिलं आपण बेसिक? वेन वी कन्सिडर अबाउट hot reservoir, it is known as source, and when we are dealing with cold reservoirs, it is known as sink. तर आपल्याला सिंक म्हणायचं आहे. हॉट रिझर्वॉयरमध्ये हीट इज बिन गिवन आउट. हॉट रिझर्वॉयर हे सोर्स म्हणून काम करतं आणि ते वर्किंग सबस्टन्सला हीट प्रोव्हाइड करतं. आणि सिंक काय करतं? मग सिंक ॲब्सॉर्ब करतं हीट. ओके. सिलेंडर, सिलेंडरचं काय काम आहे? तो वर्किंग सबस्टन्स जो आहे तो कुठे आहे? तर तो आहे एका सिलेंडरमध्ये, आणि त्या सिलेंडरमध्ये एक पिस्टन आहे विच इज मूविंग. तर जर का हीट प्रोव्हाइड केली आहे इंजिनला, तर हीट प्रोव्हाइड केल्यानंतर पिस्टन काय करणार आहे? मूव्ह होणार आहे इन अपवर्ड अँड डाऊनवर्ड डिरेक्शन. हे कंटिन्युअसली मूव्ह होणार आहे. आता हीट आपण म्हटलो आहे की हीट इंजिन आहे तेव्हा इट कम्प्लिटली डिपेंड ऑन द हीट. मग आता त्या हीटच्या प्रोव्हाइडन्सवरून 2 टाईप पडलेत त्याचे. जर का इंटरनली हीट आपण प्रोव्हाइड केली तर त्याला म्हणायचं आपल्याला इंटरनल कंबशन इंजिन. आणि जर का एक्सटर्नली हीट प्रोव्हाइड केली जाईल कुठल्याही इंजिनला तर त्याला आपल्याला म्हणायचं आहे एक्सटर्नल कंबशन इंजिन. ओके, सो हे 2 टाईप्स आहेत इंजिनचे. त्यानंतर हीट इंजिन नेहमी 3 बेसिक स्टेप्समध्ये फॉलो केलं जातं. एक सोर्स, वर्क डन आणि सिंक. असंच लक्षात ठेवायचं आहे तुम्हाला. सोर्स म्हणजे काय, जो वर्किंग सबस्टन्स आहे विच ॲब्सॉर्ब द हीट विच इज गिवन बाय द हॉट रिझर्वॉयर, म्हणून सोर्स म्हणतो आहे आपण. सोर्सकडून हीट घेणार आहे, हीट घेतल्यानंतर वर्क डन प्रोड्यूस करणार आहे आणि सम काइंड और सम हीट इज बीन ॲब्सॉर्ब्ड. कुठे ॲब्सॉर्ब केली जाते, सिंकमध्ये. सो द थर्ड स्टेप आहे सिंक. मग आपण सिमॅटिक डायग्राम पाहिली, त्या सिमॅटिक डायग्राममध्ये आपण हे पाहिलं की ॲरोज जे आहेत ते ॲरोज फ्लो दाखवतात त्या एनर्जीचा. एनर्जी कुठे कुठे जाते, एनर्जी एक तर ॲब्सॉर्ब केली जाते, एक वर्क डनमध्ये कन्वर्ट केली जाते आणि एक इट इज गिवन आउट टू द कोल्ड रिझर्वॉयर. सो असे ते ॲरोज कन्सिडर केलेले आहेत आपण. सो आपण QH, QC आणि Q या टर्म्समध्ये मॅथमॅटिकल इक्वेशन फाइंड आउट केली. अँड व्हॉट वॉज द मॅथमॅटिकल इक्वेशन, Q इज इक्वल टू QH प्लस QC. आता यामध्ये QH आणि QC यांना आपण पॉझिटिव्ह आणि निगेटिव्ह या दोन्ही टर्म्समध्ये कन्सिडर करणार आहोत. ठीक आहे. अँड वर्क डन बघितलं आपण. आता सायक्लिक प्रोसेस आहे. सायक्लिक प्रोसेसमध्ये वर्क डन हे फक्त हीट इंजिनवरती डिसाईड होतं, हीटवरती डिसाईड केलं जातं. का, तर थर्मोडायनॅमिक्सचा फर्स्ट लॉ काय आहे आपला, Q इज इक्वल टू डेल्टा U प्लस W, बरोबर. पण जर का सायक्लिक प्रोसेस आहे तर डेल्टा U होणार आहे 0. सो हा Q जो आहे तो दॅट विल बी नथिंग बट वर्क डन. म्हणून W इज इक्वल टू Q आहे इन केस ऑफ हीट इंजिन. मग आपल्याला Qची व्हॅल्यू माहीत आहे. Qची व्हॅल्यू काय आहे, QH प्लस QC. या आहे Wची व्हॅल्यू. मग यानंतर आपण जसं म्हटलो की आयडियली हीट इंजिन सगळं ॲब्सॉर्ब केलेली हीट कन्वर्ट करायला पाहिजे नाही वर्क डनमध्ये, पण तसं होत नाही. सगळी एनर्जी वर्क डनला लागत नाही. तर सगळी एनर्जी, त्यातली काही एनर्जी इज कन्वर्टेड टू वर्क डन आणि काही एनर्जी ॲब्सॉर्ब केली जाते, बरोबर. मग जी थर्मली ॲब्सॉर्ब केली जाते त्याची काहीतरी इफिशियन्सी असेल, टेंडन्सी असेल त्याची. सो त्याला आपण कन्सिडर केलेलं आहे ईटा. सो दिस इज नथिंग बट ईटा. ओके, सो ईटाची व्हॅल्यू काय होती, ईटाची व्हॅल्यू इज नथिंग बट W डिवायडेड बाय QH. हेही पाहिलं आपण. मग आपण Wची व्हॅल्यू पुट करून आपण त्याला युनिट आहे की नाही ते फाइंड आउट केलं. तर युनिट काय आहे, काहीच युनिट नाही, कारण यात दिस बोथ टर्म्स आर हॅविंग सेम काइंड ऑफ युनिट. ओके, सो दिस इज ऑल अबाउट द हीट इंजिन. सो आय होप यू ऑल गॉट दिस आयडिया अबाउट हीट इंजिन. म्हणून मी एका लेक्चरमध्ये फक्त एकच पॉईंट घेतला आहे याच्यामध्ये, विच इज हीट इंजिन. कळालं आहे, बेसिक प्रिन्सिपल त्याचं, देन एलिमेंट्स, देन स्टेप्स, then mathematical equation and schematic diagram. असे 5 पॉईंट you are going to remember while you are studying heat engine. Okay, so thank you so much.